We want to introduce the CONTREX project, which is mainly about mixed criticality. What is mixed criticality? We will try to explain this through the following use case. We will use a quadcopter as the example here, but similar situations can be found in cars, airplanes, mobile phones, and telecom networks. It is a quadcopter equipped with a camera and meant to film sports events like a football match or similar. The electronic system consists of two devices, the avionics and flight control system that executes the flight commands of the pilot, and the camera control and image processing system that captures videos and sends them to a television screen. The flight control is a high criticality system. When it fails, the quadcopter will crash land. This is dangerous if it crashes into a crowd of people and might lead to serious injuries. Failures of high criticality systems are not acceptable. The camera system is a low criticality system. When capturing high-definition videos, the camera system heats up significantly. When a certain temperature threshold is reached, the camera system has to be turned off for a short while to cool down, before it can be turned on again. If the camera system fails, we have no video for a while. This is acceptable as long as it does not happen too often. Okay, we have the high criticality system. We cannot accept any failures here because it is safety relevant. But ensuring such a high dependability is not for free. It comes with higher hardware costs and higher development costs. The camera control is less critical. Some failures are acceptable because it is not safety relevant. Hence, it requires less expensive hardware and less development effort. Having the two systems both in one quadcopter is possible because they are strictly separated and can operate in isolation. We want to reduce this separation and integrate both systems into one device. With this, we are able to use one modern and more powerful computer instead of two. This allows reduced hardware cost, energy consumption, and weight. Now we have a problem. The two systems influence each other. When one gets hotter, the other one follows. And when one gets too hot, the other one does too. But now we cannot turn them off to cool them down, because we would shut down the flight control as well, and the quadcopter would crash. In the CONTREX project, we support engineers to safely integrate different parts of a system into a single device. We develop tools to predict and control the temperature of electronic systems, which enables continuous operation of all safety-relevant parts. With the CONTREX tools, we are able to integrate subsystems with different criticality requirements into one device. This is not limited to two parts. For instance, we can add a subsystem for wireless communication or status logging. With this, the results of CONTREX help to reduce costs for device hardware and development, but not at the expense of safety.